Hello, in this video I'll be demonstrating to you about arc length as well as area of a sector. So first of all, you need to understand that in a circle, you can break up circles into, for instance, this form. And when we break up circles into this form, we can have a major sector where this theta is more than 180 degrees. And theta here, right? Theta is actually like the alphabet X, the unknown X. It is to represent the angle. Okay. So if you have a major sector, that means the theta, the angle size of that sector, is more than 180 degrees. So you can have 180 degrees up till 360 degrees, and that's the maximum the angle of a circle can be. And okay, 180, actually more than 100, so maybe 181. Okay. Whereas for a minor sector, minor means smaller. So minor sector, the angle of the theta is less than 180 degrees. So you can have as low as 0, but that would mean you have no sector, up until maybe 179. So if you're at 180 degrees, then there's neither major or minor because it's exactly half. You have two equal halves. There's neither, both are sectors. They're not major or minor. Okay, so having that understanding, there are two formulas to remember. You have to remember, it will not be given in any exams. So the first one is called the arc length. So understand that finding length is talking about finding how long something is. So it'd be in centimeters or meters, for instance. Whereas area of sector, when we talk about area, then we're finding the size of the shape, how big or small it is. That would be perhaps centimeter square, or could be meter square. Those are examples. So there's different units, different formulas as well. So but they're pretty much similar in the sense that you still need to find the theta, the size of the angle of that sector, over 360 because the entire circle is 360 degrees, and then times by for arc length 2 pi r. Now 2 pi r actually is the perimeter, or what we call the circumference. Okay, in circle we call it circumference, so circumference of the circle. So it's the outer part here. Whereas area of sector, we're using pi r square because this is the area. This gives us the area of the circle, the one that is inside. So take note of the difference between the two formulas. So let's look at some examples. Find the minor arc length AB. So since it's specifically mentioned minor, we're going to be focusing on this segment here, not the bigger segment. And when they ask you to find a minor arc length, so we're actually finding this part here, talking about the length. So part of the circumference of the circle, just this part. We don't want the entire circle, but just this part. So to find a minor arc length, we're going to use theta. The size of the sector is 45 over the entire circle, 360, times 2 pi r, right? That's the circumference of the circle. So 2 pi, and you find r. So 12. Okay, so if we use this formula to find the arc length of the circle, okay, so just key in this data into the calculator, and give me a moment, times pi, that will give us 9.4247. So in the calculator, it will show you a string of numbers. We're going to write down 5 numbers first and eventually round off to 3 significant figures, which is 9.42. First 3 numbers, and then the next number is 4, less than 5, therefore 2 does not change. This will be in centimeters, assuming it's centimeters, okay? No, there's no square, okay? Centimeters, and we write here 3 significant figures. Right, that's how we find the arc length. Another one, which is find the area of the minor sector. So if you recall, area of a sector, the formula is theta, which is 45 degrees, over 360 times area, right? So area of a circle is pi r squared. So it'll be pi r, which is 12, this is the r, and then don't forget the square. The square belongs to the 12 only, so make sure you key in the correct things into the calculator. Right, key into the calculator now. You get 56.548. Again, 5 digits, and round off to 3 significant figures. 1, 2, 3, so 56.5 centimeters squared. Okay, assuming this is in centimeters, so you round off to 3 significant figures. Alright, that's it. Thank you very much.